let's return to that program in NetBeans we've been writing with the grid. If you would, could you please open your programs? I called mine grid 2. I think you called it grid. But you should have something where if you hit build and then run, it prints 100 grids all separated by 15 spaces, and there's a hole in the grid. Okay. Everybody got it open? And does everybody have it working? Because I want to make sure we're all on the same page and nobody's getting left in the dust. Everybody's working. Awesome. Okay.
At this point, should the hole be moving or just staying?
At this point, it's staying in the same spot because we didn't tell it to move. And in fact, it's not really looking like an animation. It's just looking like a great big document with a whole bunch of squares inside of it. And that's all we have, but I think it's been quite a bit of work to get to that point, hasn't it?
Yeah.
Okay. Let's take a moment and review what we've done. And I want to make sure you really understand your own code. So while the last few people are getting that open, let's just walk through it. Okay. Package grid 2. What do you suppose that's about? Essentially, when you make some code, package is a place for it to reside. You don't actually have to even have that line. I think NetBeans injected it automatically, and you can write Java programs without putting it inside of a package. But putting it in a package kind of gives your code a name to associate with. This line, don't think of it as doing anything. Think of it as giving your program a name. Okay? Class grid 2. I'm going to talk a lot about classes when I get to my lecture after lunch today. So I'll just come back to that. But suffice it to say, a class is a place where methods can go. And we only have one method. It's called main, or function or procedure or whatever you want to call it right now. We'll differentiate those later. Main is the one recipe that we have created. So this whole time we've written one recipe. It's named main. Main is where it all starts. And inside of it are just instructions for the computer to follow. It starts here, it does this thing, then it does that, then it does this, then it does that, then it does this, then it does the next one, and so forth until it's done. Okay? Everybody with me on what all this gobbledygook is about and what it means? Any questions? Where were we? We run, we get this code. Okay. Sorry about that. Now, that I just added. We have these instructions. I'd like to walk through step by step and just make sure you know what everything's about. Is that okay? Okay. This int x is 20, y is 9, height is 20, width is 50. What's that all about? What does that mean?
20 is
So these are all variable declarations. To be clear, this portion of the line is a declaration, int x, that declares a variable, meaning it says, heretofore or hereafter, when I say x, I'm referring to this variable that I am declaring at this moment. And the equals 20 is called an initialization. We're saying, okay, put a 20 in that variable. We've declared 4 variables, x, y, height, and width. What are the meanings of these variables? Here's how I would describe it. If we have, if I had a ruler, I would say width is from here to there, right? And I would say height is from here to there. I gotta watch out for those things. Okay, I would say x, sorry about that, is from here to there. It's the horizontal position of that hole that I stuck in there. And I would say y is from here to there. It's the vertical length of that dot. Now, notice something. Those of you that are familiar with, that use a lot of Cartesian coordinates in math, we usually say x is the horizontal position and y is the vertical position going up, right? Well, in this case, x is the horizontal position going over, which is just what you expect, and y is the vertical position going down. Does that bother you?
A little, it did at first.
Okay, well,
But I get it.
yeah, I guess at this point we refer to relativity, right? If you're traveling 5 miles per hour and Alice is traveling 10 miles per hour, how fast is Alice going relative to you? Well, either 5 or 15, depending on whether you're going the same direction or the opposite direction. Don't know where I'm going with that. The point is, up and down, they're just concepts, right? If we can assign a number to mean anything we want. And in this case, down makes sense because this thing works like a typewriter. It goes ding, 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 right? And so left to right happens and top to bottom happens. So we're just calling those things X and Y. So X is now horizontal overness and Y is vertical downness. And that's just the way it is because that's the way we wrote it. Yeah.
You have another way of explaining that to students who've never seen a typewriter.
Ah, good question. Well, I guess when you read a book, you read left to right, top to bottom. But that, of course, is an artifact of, well, no, that came out long before typewriters, didn't it? So somebody picked that arbitrary frame of reference long ago. You could really say the X being left to right and horizontal is an arbitrary thing. We could have just as well assigned X to be the vertical axis, and we could have assigned Y to be sticking out of the page direction. It's just we didn't because it's really hard to draw off of the page.
Can you program the y-axis thing? I mean, you know, x, y. You understand that? X, y.
Oh,
I mean, you've got these
can you program it so Y goes up and Z comes out?
z going out.
Yeah, there are no hard rules in anything about computers. It's all however you wrote the program. So the only reason I'm saying Y is down is because I fell into it by convenience of the fact that when I print things, it tends to go down.
Okay, I mean, if you put a y coordinate on that, would it make it a cube then, or appearance of a cube?
Ah,
That's what I was asking.
there is no built-in function that prints in pseudo 3D for you. Now, such a function could be written. There's not one built into Java. So if you want to spend a lot of time with me, we could produce such a function and then use it. And yeah, there are no rules about what can or can't be done. We have pixels to work with. And if you're willing to get your hands dirty and manipulate the pixels, we can do all the math in the world. And we can build, you know, things that look pseudo-transparent. And we can build a full-on ray tracer. And people have. So it can all be done. I wouldn't recommend doing that yet. I'd wait a few years until you're pretty comfortable with this stuff. Yeah. So right now, we're going to stick with Y being down just because it's going to save you a whole lot of time and effort. In computer graphics, it's pretty standard to assume that Y means the downness. The origin of the screen is considered to be the top left corner. Whereas in math, we think of the origin as being the bottom left corner. And, well, assuming you're in quadrant 1. But it doesn't make a difference. It just means you have to think a little bit differently. Okay. So we know what x, y, width, and height mean. And they mean whatever we want them to mean. But that's what we want them to mean. Now we've got a whole bunch of loops here. I have this loop that's counting to 100, this loop that's counting to 15, this loop that's counting to height, and this loop that's counting to width. Now, this loop wraps all of the loops. This loop comes before these loops, and these two loops are nested, meaning one's inside of the other. Does it really matter? Could we have just put this loop that counts to 15 wrapping around the other loops? What do you think? What if I put an open brace here and a closed brace here? Now it's confusing because it's not tabulated, right? Here, let me tabulate it the way I should. Will that make a big difference? I claim that it will. Here's why. I used to be printing only 15 lines, and then after I printed 15 lines, then I would draw a grid. Now I'm drawing a blank line followed by a grid 15 times. Can you see how that subtle change made that difference? Because what the loop does is it's going to repeat that many times everything that's inside of its braces. So if I actually run my program now, instead of 100 grids, I'm going to get 1,500 grids. And they're all going to be separated by one space. Unless I have a compiler error, which I do. Yeah, let me... Oh, haha. Look at this error. I just created a nasty error. Look, I'm using int j right here, and I'm using int j right there, and they're both inside of the same scope.
Yeah, I was going to say, I don't have J there.
Well, let's just call this one JJJ, which differs from J. And now I build, now it runs, now I run it. Notice my grids are only separated by one space. And if I count them, there's actually 1,500 of them rather than just 100 of them. So it does make a difference. Okay, you asked me to go up.
Well, because when I saw that J, I thought you had messed up, but,
Oh, and I had.
okay, all right.
Okay. I'm going to press Control Z now and put it all back. Okay, this is back to where we were.
But you still have int J equals 0.
I do.
Not be I, or
Let's
a
talk.
different variable?
Let's talk about scope for a minute. So I am using the letter J twice here. That's kind of bothersome, isn't it? I mean, it is confusing. Well, I didn't need to be doing that, so why bother? Why don't I just change that to a Z?
Thank you.
Okay, if it makes you feel better, great. Frankly, that's a great idea. If it helps you as a programmer, what helps you is usually a good idea in programming. So I strongly recommend you do that. But just for your knowledge sake, why was it technically okay for me to use the letter J in both places? The reason is because the scope of it only lasts from here to here. And so it's like that variable didn't exist anymore when I started the next J.
Once you get to 15, it's done with that J, and it can go on to the next one.
Right. Now one could arguably say, imagine you write a function and you use the variable x in it. Can you write a different function with the variable x in it? And can that variable have a different meaning?
Yes, but how confusing.
Yeah, but you'd run out of letters really quickly if you claimed to, I used an x once, therefore everybody in the world can never use x because x is only meaningful in my program.
But as a,
Yeah, if you're reading code, you need to understand what the language does. If you're writing code, you need to understand what you like. Basically, what I want to say is you guys are making the right arguments. So I don't want to give you an authoritative answer. All your reasoning is spot on. You're exactly right that, yeah, it's less confusing if you use unique variables every time. On the other hand, if you're going to be writing code a lot, it's kind of nice to just have a default way of doing it. On the other hand, that can be confusing. And on the other hand, how many hands do you have? There's arguments for and of all of it. The way the language works is whenever you have a brace, the brace defines scope. Okay? So anything I declare inside of, say, between these two braces exists only for that duration, and what you do outside of it has nothing to do with it. So whenever I say I here, it's only going to look for an I between those two braces. And if there was an I somewhere else, it doesn't matter. Well, that's not technically true. It's going to go all the way up to the start of the function, but it's going to end with the last brace there. Because I notice I'm comparing to x here, and x was actually declared way up there.
As long as you haven't declared, right? If you declared an I at the top, you can use I at the bottom. But if you didn't declare I, you can use I inside anything message.
Yes. The place it's declared is where it matters. Because x is declared right here inside of this brace, x is valid everywhere from this brace all the way down to this one. And because j is declared right here, it's technically like it's inside of this brace. The for loop actually slightly precedes that brace, but you're supposed to think of it as being part of that scope. That's the way the for loop is. So J is valid from this brace all the way down to that brace. And notice that this for loop is outside of it. So if that one uses a J, that's technically okay. Whether or not it's aesthetically okay, I'm going to agree with you. I think using a J right next to another J it could mislead people.
Does that
I
mean you
can
have
see
to
it both ways,
declare
though.
it again?
What's that?
Does that mean you have to declare back at the beginning then, again, if it doesn't, does it?
So if I declare J right here, which I can do, now I cannot use J in both cases. Because it's going to say, hey, there's already a J and you're making another one. Now if I don't declare it, now I can use J in both cases, but in both cases I'm using the same J. I'm using this one.
You only put int on it when you declare.
That's correct. When you say int, you're saying make a brand new variable, make one that I've never seen before. And that variable will last from where it's declared to the end of the brace that preceded it. That's how the scoping